Okay, we're back. At the end of the last script, we had run a command to take the data set and average the marriage rates for women aged 25 to 29 by country by half decade. So this we group by half decade and by country code. And then we created a variable called marriage rate, which is the mean by half decade and by country of the data value, which is the marriage rate. So that if a country was observed maybe 3 times during the half decade, we'd now have the average of the marriage rates for that country for that half decade. And we took a quick look at what the data set looked like. And indeed, we have half decade, ISO 3, and then the marriage rate for that half decade. So now we're going to go and merge this with the WDI data. So we'll find our WDI data. Maybe we should read in the WDI data again. So I'm just going to read it all in again. Maybe I'll copy this here because we're doing something a little different there. And so we'll copy this and we'll read in the WDI data and rename it and just keep the variables that we want. And now we're going to left join by year, by ISO C3 and year, right? Was it called year here? No, it's called half decade here. So I need to change the year variable to be half decade. So I'm just going to so with WDIM, I'm going to rename the year variable to be half decade. So we'll rename half decade equals year, and that way we'll merge by that. So we'll take whatever the observation was for that year that begins the half decade, that'll be the observation for that year. So I'll run this. Left join columns must be present in the data. So the WDIM has half decade, and this one has half decade, ISO 3C, ISO 3C. This is an integer here. This is half decade is a number here. So, oh, I see. The ISO C3 here is a character. Here it's a character. So why is it not merging? I'm going to pause for a second while I try and troubleshoot this. And I see right away, this should be half decade. And sorry about that. So now we have it merged. So now we have our data set every half decade, country, the marriage rate, GDP per capita real is missing in 1970. Oh, you know what? That GDP data only starts in 1980. There's another gross national product per capita that's available for the whole time series. Not going to worry about that. We'll just use this GDP data. Well, let's go and find. So we want the World Bank gross national product per capita, and then from the World Development Indicators, that's GDP per capita. We want gross national product, GNI. This is what we want, gross national, but we don't want current. We want real. So let's look at GNI per capita. So GNI per capita, and then we'll add real. Let's see if that gets us. That's current international. Come on, where's real? Let's look and see if maybe that's current US. Oh, here it is. Constant current. GNI per capita constant. Here we go. GNI per capita constant $2015. So let's constant $2015. This looks like what we want. So here's what the variable is right up here. So we'll copy this and then we'll go to our R, and instead of GDP per capita, we're going to calculate GNI per capita. And that's what we'll select here. And so let's run that again. Oh, we need to tell it here to get not the GDP, but the GNI. Okay, so we'll run all this again. And now hopefully what we're going to see is our GNI per capita data is not going to be missing for the 1970 period. Instead, we'll see it showing up here, not as missing NA, but as there. And here it is. Well, it's missing for some still, but it's not missing. We can look here and see GNI per capita. It's here for a bunch of them. So it's still missing for a bunch of them, but it's there for many others. And actually it's still, so sometimes we have GDP and we don't have GNI. So this is annoying. In the, it's hard to construct coherent systems. So GDP actually seems to be more available for many countries than GNI is. GNI seems to be missing for many countries in the early years. But then if we get to, oh, so GDP only starts in 1990, yeah. So that's when we see GDP being recorded, and then GNI sort of stops being recorded. Well, so a little problem with data comparability. Now we want a scatter plot, right? So let's go up and get our scatter plot. Here's our ggplot. Well, I'll just copy the whole thing. So we're going to take the same thing. We're going to filter for after 1970. We're not going to limit this to Africa now. So we'll take this out. We'll group by year. Now we don't have to do, we're going to have, we don't have to group by the, we've already done the average for each country. So, we don't need to group. We already did that. So here we're going to have the half decade. And then here we're going to have, what did we call the variable, the marriage rate, rates. So we're going to have observations for every country for every half decade. Let's see what this looks like. Oh, we filtered, we need to filter half decade greater, which won't filter anything because the half decade started. And okay, there we go. These are all our every dot here is a country observed its marriage rate for that half decade. And so we see the countries declining over time. Let's group the countries by region and color them by region. I think we can do that pretty easily. So here do we have a region variable here? We actually don't have a region variable in our data set. Guess we didn't keep the region variable. So it's not there. Well, we could group it by region, and that would be interesting to have the dots colored by region. Let me pause. Well, that's so that's by half decade. But right, we wanted to do this by GDP. So let's do this by GDP level. So the x-axis is not the half decade, but the x-axis is the GNI per capita. And then we can take out this continuous, that scale, because that scale should be different. So let's see what it looks like when we run it here. Yeah, there we go. Nice, nice graph. GNI per capita. The higher GNI, the lower is the marriage rate, as we might expect. Young women get married later. So these are very poor countries where almost 75% of women are married. As countries get wealthier, they get higher. Did we drop all the ones under 10,000 here for some reason? Let's go back. Maybe that was. Uh, why aren't we observing any wealthy countries? Maybe our marriage data was only for developing countries. Um, Looks like that's the case, that our marriage data is not including any wealthy countries. So GNI per capita is, did we drop anything here? Half decade? Don't see that we did. Um, okay, well, that gives you hopefully a better idea of how to do the scatter plot. We can do some regressions. Let me pause and I'll rewrite it and come back. Okay, so I quickly typed out the regressions. We'll run 3 regressions. We'll do cross sections. Remember, this data is a panel data, so we're observing countries over years. If you've taken Econ 173, you know a little bit about how to analyze panel data. We'll just run regressions with what are called the cross sections. So we'll subset the data to be half decade equals 1980, then half decade equals 1990, and then half decade equals 2000. So we'll just restrict our data to those 3 half decades. And so we'll run the 3 regressions and then we'll display the regressions. Let's see what we get. Here's our displayed regressions. So we have the marriage rate in all 3 cases, not statistically significant for the 1990s, but the marriage rate declines by about 0.01, so a 1 percentage point decline, it would seem. The marriage rate, let's go and take a look at our data set. The marriage rate is 80. Okay, so it's a percentage. So here we would say every $1,000 increase in GDP. So 1, 2, 3 is about 10 percentage point decline in the marriage rate, roughly, right? So this is for a $1 change in GDP, but of course a $1 change in GDP is very small. So for a $1,000 change in GDP, the marriage rate declines by about 10 percentage points. So that seems about consistent with what we see in our graph here. GDP goes up by 1,000 from 2,000 to 3,000. The marriage rate goes down by about 10 percentage points. So we're just finding the same thing that we found in the graph here, but now with the regression analysis.